Okay, so let's look at a few examples and see if you guys can identify these different types of distributions. Okay, if we have a histogram that looks like this, okay, what is the shape of this distribution? Most of you probably recognize this as a normal distribution, which it is. What about this one here? Now be careful because a lot of times the distributions aren't quite as clean as we might like to see in our examples. Okay, but this is a distribution of some real data. How might we best characterize this, given the different distribution shapes that we've covered so far, this distribution here? I would probably refer to this as a uniform distribution. If you look on the axis, for example, at the counts here, so look at the y-axis. Okay, the range in the smallest value here, with a count of about 7 or so, to the largest with a count of about 14 or 15. That's not really a very large range across the scores. Okay, so although there might be a couple scores that occur a little bit more frequently than the others, these are mostly occurring with about equal frequency, a difference of only about 2 or 3 count or n between most of these values. So this is probably the closest you'll see to a real data example of a uniform distribution. So now we're going to give you guys a chance to answer a couple of these. Okay? So what I want you to do is take a look at the following two graphs here and make sure you write down the shape that you think you see in the corresponding distribution. You'll need these answers for the quiz that's relevant for this lecture. What shape do you see in this first graph here? What would the shape of this distribution be? Got it? Then we'll move on. And what about this distribution here? What might best characterize the shape of this distribution? So now that we've looked at different types of distributions, okay, and some of their properties like symmetry and shape, remember what all these did was to show us every single data point or every single value, okay, for a single variable in our study. Well, the last thing we're going to cover here is somewhat of a similar representation, but what if we wanted to summarize two different variables together? As we've seen a lot of times in what we're interested is comparing or relating an independent variable to a dependent variable. Well, it's pretty easy to do. What we can do instead of just plotting the number of people, okay, on one single axis, is to plot both of these variables together. Okay? Typically, the convention that we use is to plot the independent or predictor variable on the x-axis, shown at the bottom here, and the dependent variable, or variable to be predicted, on the y-axis. Okay, so let's look at an example. Let's say that we want to predict somebody's weight based off of their height. Okay, now this might not be a very momentous example for behavioral science, but hopefully it'll illustrate the point. Well, again, remember before how we were dropping individual points down onto that x-axis, okay, and then we looked at how they stacked up to create a frequency distribution. Well, you can think of a similar thing here, but now what we have is important not just where it lands on the x-axis, but also where it's positioned on the y-axis. So now if you want to think about it, think about throwing a dart or a point or whatever you want to call it at the screen relative to each data point that we collect. So let's think about, say we take one person, we measure their height and their weight. And if they are 5 feet and 125 pounds, okay, so they're 60 inches and about 125 pounds, they're still going to be a single point represented on here. But now it doesn't drop down onto the x-axis. Now where it's located sort of above the axis too, relative to the y-axis, is also important because that conveys this person's weight, whereas where they're situated along the x-axis indicates their height. Okay? A second person who might be 6 feet, 165, 170, okay, is going to show up here. Again, we can read this person's height by following that point down to where it would meet the x-axis, and identify that person's weight by seeing, again, where it would meet the y-axis. And again, as we continue to do this for each person that we measure, okay, then you can think about it as throwing all these different points onto the screen, and we start to get a collection of points that looks something like this. Okay, these points scattered all over both x and y axes is exactly why we refer to this plot as a scatter plot. Something I'm sure you guys encountered in Stat 261 when you talked about correlation. And if you guys covered regression in that context as well. And again, we'll return to scatter plots and interpreting them when we talk about correlation in this course in more detail. Okay, what we want to do is to illustrate right now what information a scatter plot is conveying. Now, it's important to realize how a scatter plot of two variables relates to the frequency distributions we just saw looking at a single variable. And one way to think about it is if we take a scatter plot such as this one here, okay, if we're only interested in one variable, say that we're only interested in height, we can use this exact same information to create a frequency distribution of the heights of all the people that we've measured. And we would do it, as you imagine, just by dropping all these points down onto that x-axis. And now what you can see is that, again, we have a frequency distribution here. Okay, we might probably want to create a histogram in this situation, which we're not going to do now, but you can see where we got here from our original scatter plot. Okay, what you can do is to, in a sense, ignore one of the variables or one of the dimensions. If we don't care about weight, or if we want to get a sense of just how the height is distributed based off this single display, you can sort of imagine, okay, or visually imagine dropping all the points down like this. Now you can do this for the other variable as well. If we have a set of points and we want to imagine how are these distributed across the y-axis, that is, what is the distribution or frequency distribution of people's weights in our study, you can do the same thing and drop them onto the y-axis. Here you can see that they're somewhat normally distributed in terms of the weights of the measurements in this study. Now that concludes this lecture looking at different types of distributions and different displays of entire data sets. We looked at the frequency distribution for a single variable and the scatter plot, looking at how that's an extension of a single frequency distribution to relating two variables together. We looked at some of the different shapes of these distributions and other properties such as symmetry. Okay, and it's going to be important that you guys have a good grasp of these concepts because we're going to be using these sorts of terms over the course of the semester. And we're not going to stop at each moment to think about, oh, what is a frequency distribution really showing us? What is a scatter plot really showing us? You guys should be able to quickly and easily digest the information that's presented in these displays of data, okay, without having to work too hard thinking about what they're really showing you. Okay, hopefully that's going to be second nature with a little bit of practice. So that concludes this quiz. You should now be prepared to complete, or that completes this lecture. You should now be prepared to complete the quiz associated with this lecture on the Course Nika site.